Well, hi, good morning, and thank you so much for joining me here. It's February 11th, and it's 0 degrees outside. It's a little more normal for this time of year. Still a bit on the high side, but it looks like the warm spell is over, and we're just heading into a kind of a normal, -5, 0 type situation here, and still no snow. No snow this winter. So there in front of the radio, you see all the dead soldiers that I removed from it. All been replaced. Not to forget this big guy too. And we'll deposit them there. And what's in store for today? So the next step, I think, is to put the string on this radio, the dial string, which is entirely missing. So we get no hints from that. I'm going to look for a string guide in a few minutes, but first I think I'm just going to study this with my own eyeballs and just make some observations here. 3 different sections here. 2 of them are buffed up. Looks like the string was in these 2. Maybe not in this one. There's a big slot cut in the radio chassis for the string to go through, right through here. And down there you can see the tuning off. Nothing on it. You can just feel how terrible that is. Just a little bit of lubrication will change that completely. But right now, see, when the string is on and everything's hooked up, and you turn this knob and it's all binding, you don't know where it's binding. Often it's binding right here, right where the knob is. So there we go. Over here, there are 2 pulleys here. 1 pulley here. Now, how can the string get from here to here, or to anywhere? It must go right back. It must come over, because of the angles. There's no way to get off the bottom here and head over this way, or head down there, or anything. It's got to go back. So it probably comes over the top, goes under, maybe it comes up again and goes over. This has to, well, these can actually turn 2 different directions. If they had to. Would they do that? And then somehow down, well, it can't go down this way because it can't make it to the piece in there. It would have to also, well, how does it ever get from over here into here? What is going on here? So the string could come from here, it could come out on an angle and reach here. It would probably stay. You know what I think they've done here? I think there might be 2 strings. There might be one that's simply going down to the knob here and driving this. And then another string coming off this, which is moving the pointer somehow. I think the string could come back and just loop around here and go back there with that angle. But I don't see any offsetting pulleys. Like there'd be a pulley in here, you can come down and offset with. But then you'd have to offset again here. Or oh, wait a minute. Right where I'm standing, and just like the camera angle here, you can't see that there's another set of pulleys. Oh my gosh, I almost missed it. Another set of pulleys right down here. Once again, looks like there's 2 independent pulleys there. Well, that doesn't make it any easier, does it? That actually makes it much more complicated. Now, how's all? I mean, obviously all this stuff lines up here just wonderfully. So you can see a string going up and down there. Still doesn't really. I need a string diagram. I'm not going to get anywhere without one here. Like that thing about how many ways can you seat 10 people around a table. Now, I haven't got the number right, but off the top of your head you might think, I don't know, 20 ways? No, there's something like 900 ways to seat 10 people. Something like that. Same thing here. There's probably a dozen different ways to run a string, and only one of them's going to work. I better find the string diagram right away. Good luck to me. Just as I was about to give up on finding a manual for this radio, bingo, I found it at this website, philcoradio.com, and here we are. So notice it says Philco Tropic Radio. So this was actually made in a manner to go down into tropical areas. I don't think they mean the southern United States either. I think they're talking about South America, and sell these as radios that can take the heat, so to speak. So of course here's the stand-up version. This is the one I have sitting right beside me here on the floor. And we're just going to whip through this very quickly just to see if there's anything really that stands out. Calibrating dial backplate. You bring out your ruler to do this. Oh, looky there. There it is. Drive cord installation details. Oh my gosh, what's going on here? There's strings going everywhere. Wow. Excuse me. Well, at a glance, it looks like there's maybe even 3 separate strings in here. At a glance. Let's keep going. We'll come back to that in a minute. Here's a much better schematic diagram for me to use than the one I'm using now, which is a little hard to look at. Looks identical, though. What? Yikes. Okay, that's definitely the radio that's on my bench. What's all alignment procedures? All laid out nicely, showing you everything you need to adjust. Fantastic. Wonderful. Such a professional job. List of parts. Trying to sell their own parts. That's a big part of the business. Revision and additions. Additions to the service manual. Oh my gosh, there's quite a few of them. Oh, is that what these asterisks meant when I saw them in the schematic? That they were changed? Line filter. There's that 800 ohm resistor. Part list corrections. Part list additions. Ooh, so it sounds like they made mistakes just in printing up the parts list, and these are the corrections, just kind of word corrections. Production changes. To suppress parasitic oscillations, a 6800 ohm resistor was added in the screen lead of the 7C5 tube. We'll have to take a look at that at some point. Oh, critical lead dress. To prevent audio regeneration, the blue plate lead of the 7C5 should be dressed down to the chassis and away from the 7B6 grid coupling condenser. Interesting. Of course, the signal coming out of the 7C5 output tube is very, very strong. And then if you have that strong signal get physically close to the grid of the previous tube, you're really setting up an oscillator with feedback. To reduce hum pickup, the white AC leads from the voltage changeover switch, the phono motor cable, and the AC phono switch should be dressed under the hold down lugs provided. Well, I'm sure they were. I mean, we're not doing anything to that. So it's however it was done in the factory is the way it is. To reduce circuit capacitance for proper alignment, the leads from this particular capacitor, the broadcast aerial trimmer, and the shortwave aerial trimmer should be dressed upward from the chassis and away from other metal parts. So these little secrets that are revealed here for this radio, they exist, I believe, in all the radios. They have these secrets. There's probably more in this radio. These are probably the critical ones. In fact, they call them critical ones. So that's why when you're working on these radios, it's not too good an idea to relocate components without a lot of thought first, to make sure you don't accidentally tip one of these things, one of these sorts of things. So we can take a look at these later, but you know, I don't hear any audio feedback or any oscillations. Don't know of any hum that's in there. To reduce circuit capacitance for proper alignment. wow, this means if you mess up these leads, maybe you're replacing this, or who knows what's going on, but somehow you've messed up the leads, the effect is the alignment becomes wonky. And I'll bet you right now that you can't figure that out while you're trying to do the alignment. You're not going to at some point go, oh, I know what's happened. The leads aren't dressed correctly from some parts inside this radio. That's just not going to happen. Stray circuit capacitance, just from leads. So we're talking about picofarads of capacitance here causing a change in the alignment. And often what I'm thinking in my mind is you want to dress all these critical wires and whatnot close to the chassis, but this one says away from the chassis. I don't know that I've ever read this kind of instruction right here. And other metal parts. I guess you get it close to the chassis or any metal part, and you picofarads start becoming more and more picofarads. You increase the small capacitance that's there, and that's the end of it. Okay, that was kind of interesting. Let's go back to the string diagram. I'm going to look at it briefly, and then I'm going to go drink some coffee and prepare myself mentally. I'm going to do some yoga and some other things to prepare mentally for this. Dial backplate calibration. Oh, that's above. So let's look here. We see the spring. So the way I make it, this string, now they've shown these pulleys not lined up so you can see them. So this is just the back pulley. The string comes along, back pulley, down. I think this is the knob. I think this is the lower pulley. What in heaven's name are they doing? This must be going around the knob, the tuning knob. This would be the tuning knob. 5 turns. This must be the capacitor. This is the capacitor. 5 turns? What do they mean by that? 5 times around? That's crazy. They're 3 turns. Well, that's more sensible. 5 turns. What is that number? That is definitely 5. Okay. This could be coming straight through here. It must go around, because if it doesn't go around, then there's no way to explain why they put this wheel on the diagram. If it just goes straight by. So if it comes down, around. Well, what is it? Oh boy, oh boy. I said I was just going to look at this briefly. Now they're showing details here. Showing details of how to run the string in the pointer. And wow. See, there's no way you can, like, there's 2 pulleys here. There's no way you drive one pulley and the other one then becomes driven, because these are not connected. These 2 pulleys turn independently. Here they're showing, wow, that looks like 5 turns there. Well, that's right. This is the capacitor, and this is the small pulley on the chassis, and this is the knob you turn. Well, it's not terribly clear what's going on there. And why did you do all this crazy cross-hatching? I think if I was the drafting supervisor, I would have been upset when I saw this. Like, they've done the same thing here, but they didn't do it up in this top part. So they're showing that there's a metal. So I guess they're trying to highlight this hole. So to make the hole stand out, they had to do something, you know, gray this in. Ugly, ugly. Yeah, Bill, don't do this on the next one, okay? And you've done it now. We'll let it go, but next one, don't do this thing. Come up, maybe, I don't know, dots or something. If we look at this diagram, so they're showing the close-up there, and here they're showing the close-up there. There's the spring, you hardly see it. Is there a section of this capacitor that has no string in it? So there's 3 possible string spots on this thing. 2 of them were polished up. I only see one of them being used here. So it looks like there's 1, 2, 3. And the string is only in this outside one. And now, is this one long continuous string doing this whole thing? Let's look at this part again here. Can you tell from this what's going on? So it looks like this string is in the, we'll call it the front roller, front pulley, and this string is in the back pulley. Well, that can't be, because you have to drive this thing, and there's no way to drive it. It must be one long continuous string. So we're looking here. This is more clear. This is much more clear. Coming around, going the back, coming down, going around, coming down here. Something happens here. I'm not quite sure. And then we're heading down onto the control. And we're coming back out. We're catching, what's the, oh, this is the wheel behind this wheel. Okay, we're going around that. And then these two strings are going to travel on an angle. So that, but anyway, we're going around. I kind of lost track of what I was doing. Going around, and we're coming back up. And there we are, going all the way around. With the spring up on top here. Okay, now, well, here's some more information, Jim. 25 foot of string. 25 feet of string. Look, it's got a part number, you can buy it. Over here they're giving you the real dimensions, are they? They're showing the loop, and then they're showing, oh, different models, different lengths. My experience with this is, if you try to cut the string to exactly the correct length you need, you're probably going to be sad down the road. I think it's probably better to try to, I guess you could cut a string extra long, and then cut off the part you don't need in the end, or try to keep it on the reel, which is what I try to do, which is stupid. But stupid's never stopped me. Okay, that's good. Seen enough. Okay, so one of my primary goals when working on a string on a radio like this is to not lose my mind. That's very much at the forefront. So, it's one continuous piece of string. It's not 25 feet, it's 5 feet. You can see on the lower diagram. They have 60 inches written there. 5 feet of string going to go into this radio. So, there's two kinds of stringy things here. Actually, it looks like there's only one kind on here, but in some cases you have to feed the string through something as part of its travel. In other cases you don't go through something, you're kind of going over something like that. So you see, like, you could fit that on later. It's not going through anything. So that's something to just take note of right at the start. Everything is like this. There's nowhere the string has to get through something. Can't even call the hole in the chassis here a through thing, because it just comes right back out again after going around the thing there. How in heaven's name do you even start something like this? Well, I look at the diagram and I see the end of the string is sitting basically over here. So why don't we just start like that? So what I'm going to do is I'm going to try and clip the string here. So I'm sort of setting up the end of the string, but I don't want to clip on the surface here. What can I clip it to? Clip it to anything over here at all. Anything at all, Jim. Find something. Hurry up, man. Time's a wasting. Here, with lots of space over here. Let me put it down like this. Just clip the end. I'm not trying to fit the string on now. I'm just trying to sort of practice how I'm going to fit the string on. That's kind of where we're at. So the idea is the end of the string is coming under what I believe is the outside. This would be the inside pulley. So would be some. You can't even get it around the first pulley. It would come up like this. So this is a string that the pointer would be on. Pointer, where's the pointer, by the way? It's just right over here, isn't it? There it is. There's the pointer. Just reassuring myself I have it. Then we come across. There's only one pulley here. What's happening here? Oh, you know what? This whole thing isn't just the other way around. What do you mean the other way around? Yeah, it is the other way around. Okay, see, that's I couldn't even get the start correct. Okay, so we're starting over here. So I'm going to clamp the string here. You notice I'm laughing a lot? Yeah, it's fake. I'm actually quite upset already. Okay, keep the laughter going. We're going over the top here. We're coming down here. This is the part that the pointer rides on. We are then going under. Going under. Okay, so I have a special tool here that I fashioned for this work, which I should have got out already. Here it is. So what's special about it is, if you look at this end here, it's got a reverse hook on it. So that's a straight hook. That's a reverse hook. So sometimes I call this my pusher puller. You get the push string and pull string with it. Okay, so we want to pull a piece here. I'm trying to not get my arm in the way. One thing about these pulleys, when you're working with them, is if the string is in the pulley the proper way, it'll probably fall out while you're working. But you can let it slip behind the pulley and go down on the shaft. See, see how that works. And then it's very unlikely to fall out. That's if you can manage to do this. There we go. Okay. Take everything I say with a grain of salt too. Okay, this is just what I do. All my videos is just what I do. It's not necessarily the best way by any means. Take some of the kinks out here. This string I bought about 10 years ago from somebody in Australia, of all places. They make string in Australia. So we're coming out the bottom of the pulley, and from the bottom of the pulley, we appear to be heading down to the back side of the chassis pulley. Back side of the chassis pulley. Yeah, I can see this is just going to be a monster to try to do. Okay, back side of the pulley. You probably can't even see the pulley with the camera angle. Back side, we come over quickly. What are you looking at? We're coming down. We go under, and then over. Yeah, wow, this is a really challenging. This is definitely in the challenging category here. So there's two pulleys here, down here too. Okay, I'm over the one pulley. What do we do now? We actually go down, it crosses the string, goes 3 turns around the knob. Around the, oh boy, how are you going to do that? Pull it through. Again, all I'm doing is just figuring out the logistics of some key things. So around the pulley, but did we, or around the controller, go the right way? So I'm looking at the diagram, and so it's the 3-turn one, and it shows it going this way. Oh my gosh, well, which way am I looking at it here? So all I've done is just tip this up, so I don't think it makes any difference. So we'd be coming over. Oh, we're coming up from the pulley. Coming up from the pulley, or down from the pulley, really. Down from the pulley, over this on the same pulley side. Okay. We've not done that. What do we got? We got something wrong already. So what I'm talking about, I let go of the string here. What I'm talking about here, you can see the pointer on the screen. So I've tied this to the chassis. Come around, and coming down. I've gone around this once. And now I got to do 3 turns. You can see how they've drawn it right here if you look very closely. This string is in the back and this string is in the front. So we're coming over top of this string. Oh my gosh, am I going to make a video of all this? This is going to take a long time to get this to go. You know. So we got to go around that thing 3 times, and let's see, the diagram is like this. So we're coming around the pulley, which we came around, going down off the pulley at the back. So we've come down around. We're coming down off the pulley at the back, but we're supposed to be at the front. We're supposed to be at the front, not the back. At the front, not the back. Now, you see, I had not cut the string from here because I'm trying to avoid the disastrous situation I've been in many times where I've cut the string and it's turned out to be 1 inch too short. And I got a big long piece of string that doesn't fit anymore. So I try to avoid cutting this to the last minute. I don't think that's going to work here because I mean you can't fit this through all this stuff. And by the time you play out enough string, yeah. So maybe I'll take them at their word. I'll cut 60 inches of string here to work with. I think that's what I've learned at this point. Because I'd have to fish it around here. Well, this isn't right, but let's just keep going because I want to discover all the areas that are going to cause brain damage. I want to discover those now. So this is going to go around a few times here. So we're just going to put it around. Don't know if it's the right way or not. Okay, it's gone around. Now, coming up from there, we go right back. We go right back to the same pulley. It looks like we go around it once and then head for that 5-turn thing. Really? Is that what we do here? So I got to pull the string. It's still up here. So the string is coming up. Look what's happened to it here. It's all tangled around in here. So it's supposed to come up, go through this pulley again. Now, is it the back or the front? It should be in the front. So we're supposed to be on the back here already, but I'm not on the back. I'm on the front. Wow, this is gonna be this is not going to be a pleasurable experience. I don't think, no matter what I do to it. Don't get caught on there. Get around the back. My tool's stuck here. Okay, now I came, oh my gosh, I can't remember even what I just did. So at any time when you're doing this string stuff, if the string should get too slack, it'll just start falling off everything you put it on. And therein lies the major source of frustration in doing this. And the more complicated the situation, the longer it takes you to do it, the more it falls off. The more upset you get. I'm pretty upset right now. I can't fit this through there. If I pull hard enough on this string, and we'll get enough slack, I can actually do this. Okay. Pull it back. Okay. So I've come across, we're coming back up from the tuning thing. It's supposed to be on the front now, are we not? Looking at the diagram. We should be coming up over the front. Oh, I have to put this back through here again. Wow. And remember, I'm not trying to install the string here. I'm just trying to discover, you know, where the emotional stress is going to come. So now we're coming up out of here, and we're heading for the little pulley. Coming up, going around, and it looks like it comes out. It's weird that it goes right around and crosses itself here. This is a strange thing. Okay, we've done that. We're around there. And we're coming up 5 turns. And look, there's 2 sections here that are polished up. We're in what looks like the outer section. 5 turns, and it looks like the turns start on the outside and work their way back. And they start, I just have to, I'm having a hard time relating the diagram to the truth here. Well, we're coming up on the inside, inside, 5 turns to the back. How can I do this? Because I have to put the spool through there. And if it were 2 turns, I could probably do a twisty thing with the string, but this is a little much. The string were cut, I'd have an easy time wrapping it. So let's wrap it the wrong way for now. Because again, I'm just discovering, you know, where the bloodletting is going to occur. You're supposed to go around this 5 times. My gosh, that's a lot. Okay, so that's probably enough for my effort. You can't have the string going on top of itself here anywhere. Now, that'll normally kind of straighten itself out on its own. Now, where are we going from here? So we're coming off. We're heading back up. We're heading back up. We're heading back down. In this case, down to here. From here, so we're coming off the 5 turn thing. We're going over the top of the back roller. Over the top of the back roller. Right. Come on. How come this got so slack? There we go. I can't believe I got this far. Okay, so now we're coming across the bottom, and we should be heading for the string, which is coming from the bottom of here, but I've just got it clamped on here. So the string would come around, and the 2 ends would meet. We get a string length here. I can cut the string. So we've got a fair bit here. It's ending somewhere in there. So if that were to come around, it would come back to about here. And I have the string. I did 4 turns here, not 25 like they asked. And I did how many on the control? I did a couple on the control, but I think it takes 3. So we're going to be a little generous here. Is there anything I missed? Does this even work? Can I actually turn this at this point and something move somewhere? Goodness knows. I don't think so. Yeah, I got this off the pulley here, so there's a little extra string waiting here. Same thing here, it's off the pulley by accident. So there's some, wow, that's pretty tight. No string there. We gotta make a spring allowance. I think if I cut this string here, I can't go wrong. So in that case, I'm going to cut it much further along because I know how this goes. You can't exactly extend the string after. Okay, I'm committing. You ready? I did it. I did it. I cut the string already. Good. Okay, so that's pretty good for a dry run. That's actually pretty good. So I just discovered that my water heater is not working in our house. The pilot light had gone out and I can't relight it, so I'm guessing the water heater thermocouple has failed, or it's gotten carboned up and it's just not producing enough electricity. So that's what I'm paying attention to now. Can't work on the radio without hot water, no doubt about that. Well, never mind the radio, let's look at my gas water heater. Here it is. Okay, so I got the type that has the built-in igniter to fire up the pilot. Pilot gas comes out here. I'm able to ignite the gas by holding down the pilot button, and I let it run first 30 seconds. Nope, in a whole minute. The flame goes right on the flame sensor here. This is a thermocouple, and this generates a small voltage which is enough to trigger the machine to keep the pilot on. This guy's probably shot, but I'm going to try cleaning it and sticking it back in just to see if by some chance, if I get that junk off it, if it'll all work again. Clean her up a bit. My water heater is about 12 years old, as best I can tell. Water heaters typically live for around 12 years, depends upon the water that's going in them. In some locations much less, in some locations much longer. 20 years would be really a long time for a water heater. How do I know this? Because I was supervising the water heaters at Toronto Hydro for a couple of years. Electric water heaters, not gas water heaters, electric ones. And that's when I learned about water heaters. So anyway, I'm going to clean this up with a little sandpaper. We're going to put it back together and see if we can get some hot water before my wife notices we have no hot water. Hurry, Jeff. Well, my attempt at cleaning the thermocouple didn't work, so I'm going to have to go and get a new thermocouple from the hardware store and put it in. And so I think I'm done for today here. Yeah, I don't think I'm going to be able to finish this today. Hot water, too important. I guess my YouTube channel is kind of about repairing stuff, so the water heater qualifies. So this is the thermocouple that I removed from along here. And here's the replacement I just bought. 15 bucks. Easy job. Should be done in a moment. Well, and like magic, it's the next day. It's the next day now. It's February 12th. And I did manage to get my water heater working again, but that turned into quite a saga. So this is the thermocouple I took out, bad one. You can see I've got the torch here because I eventually put a voltmeter on there and heated it up to see what the voltage was on this. It's about 20 millivolts, unless you really heat it high. I think that's just too low, and that's probably why this stopped working. The new one I got, which is basically identical to this to put in, my water heater didn't work. What? Would you believe in the long run I discovered that the thermocouple I bought was defective right out of the package. That's another reason why this is here. So it took a long time. So anyway, water heater's working. Persistence paid off. Did not call anybody to come and put a $15 part into my water heater. Okay, very good. Now, The string, right. The string, the horrible string. So I just kind of forgot everything, so I just need to remind myself a little bit here before we get going seriously. So I believe what I'd concluded is I actually had this installed essentially correctly. Essentially. So this was supposed to come down here. Get on this pulley. And come back up. And then be spring loaded. Right, springs. Okay, so I have a set of springs, but these aren't the most appropriate springs here. Most of these are just too big for the job. Sometimes I throw some old springs in here. I don't see any. Uh-oh. So, you know, physically, the size of the spring can be a problem. It's just too big. Maybe it's going to drag on something. This has the right kind of tension, though. But that's too big. This is probably too long. That's a little strong, too. How about this one? That's not bad. Actually, you know what? I've got a bunch in here that are going to be pretty much the right kind of size. How strong is this? That's not bad. Now, looking at this, what it means is I got to get the string to the right length within about a 1/4 inch to get the right tension on the string. I only have about a 1/4 inch of error to play with, by my estimation. Okay, so I've got a spring anyway for now, but I think it will work. So that's great. I think a couple things I need to do. I need to look at all the spots where it's going around wheels and decide if I got it right or not. Up here, where it's going around things like this. Did I get the front to back right? Did I get the, which way it's wound right? And if that's the case, then I'm almost done. I'm almost done. I doubt that's the case. That'd be just too easy. Okay, well, things are looking pretty good, but I have discovered they've got the string wound wrong on this. So what I'm going to try to do, because I don't want the whole thing to come apart, so I just want to pull those turns off, turn them around and put them back on. Which way to turn it? I think it's this way. So, and then I have to get one more turn on here also. Let's see what we've got here. Just tighten it up. Okay, so we've got it coming down the top, around, and so there's not enough here. Okay, that's 3 times around. Well, that wasn't so bad. I turned the camera on because I thought, well, this is going to go crazy. But it didn't. Okay, let me keep checking it. Okay, I've also realized the same thing is true here. I've got all these wound on basically the wrong way. I have to loosen these off, grab them, spin them right around. Well, what happens here? That would bring this piece coming over the top. Is it supposed to come over the top? Oh no. It is supposed to come over the It should come from way over here into the bottom, just as it is now. in leave from the top, which it is now. If I just take this and turn it like this will be coming in at the bottom. I think that would turn the direction completely around. I don't want to do that. Funny thing is, if I had this backwards and then I had the other knob backwards, it's possible this whole thing would have worked right. Yeah, see, my water heater attacked me a few times while I was working on it yesterday. So I think what I got to do is loosen this off, take the string off, and then try to wind it back on the proper way, which again is coming up. Doesn't look right. Okay, got to study this some more. I think there's another problem here. Okay, I think I got the rule. Bottom and back. So this is the very end of the string here anyway, so it's very easy to do this. 5 turns, eh? Okay, up on the bottom. Do we go around? Must be this way. Let me just take a peek here, because I don't want to get it wrong. So we come up and go 5 turns around and out the front, just like this. 5 times around. That's 1. 2. 3. I can't imagine going around this 5 times. This shaft's going to rotate, 5 or 6 times for a half rotation of this because of the gearing in here. This is going to travel across. 5 times? I can't believe it. I think I'm settling for 4 here. I have to leave some space in here. So I'm going for 4. Don't tell the design engineer I'm doing this. And we're coming across. And we're meeting up with the string I've got clipped here. I think we're coming across over the top. Like so. And then behind. And then we meet up with the other end here. So now it's a question of string length and spring. Oh, also testing. We have to test this to see if it's actually correct. So we need to watch which way this is going to turn. And I'm going to pretend I'm the spring, but this is not going to work very well. We just need a little bit of movement. Okay, so the capacitor is going this way. Which way is it going? Pretty clear. So it's opening as I turn the knob this way. What I would like to see is the pointer head this way when I turn the knob this way. That's not what's happening. Can I tell the pointer where the pointer string is going? I don't know about that. Let's see if I can put my finger on it and feel it. Like it's fixed here, so it's not going anywhere. Really need to test this out. trying to feel which string is tugging which way. Can't feel it. Okay, so when I push this way, this string retracted. That's the return string. The one that's carrying the pointer is this one. So this one would go this way. This is backwards. Because the capacitor is closing, we're going to the low end of the band, and the pointer is heading for the high end of the band. Well, how do you like that? I don't like that. So either it's backwards here or backwards down on the knob. I'll have to study the diagram some more. Okay, sure enough, I've got this backwards now. So let's just looks like I can just leave these hanging here. Don't everybody fall off. Take this off and rewind it the other way. The other way. Now what does that mean exactly? That means from the bottom over the top at the front. So how you count these turns here, because the string doesn't necessarily come on and go off at the same spot, so you got like a half a turn in there. And so when they say 5 turns, what do they really mean? But often the diagrams are done in such a way you can just look at the diagrams. This one's not really. It just shows a bundle of string and says 5. Okay, so where are we going from here? From here we're heading back up there, so this has got to be, I'm going to call this 5. I think it's actually 4. Again, then we're going up here, and we're coming over the top and out the bottom. Here, there we are. I'm pretty sure I got it right now. This will be coming. This is over the top. Now, so I have the ends of the string out here. This is kind of, I didn't think about this. But the whole time I've been doing it, I've left this here. You know what I can do? I can just slack this off, put this in the right position to match the position of the string. What do I mean by that? Can't have the spring coming around, so I need the spring either right at this end or at that end when this is open or closed. So as we're closed, the pointer would be down here and the spring would be up here if this were closed. So can I close this? Can I just slip it? Wow, yeah, 5 times around. five times around there. Slip it. So now we're pretending the pointer's down here and the spring will be up here. Excellent. Not really pretending. So next thing is I got to make sure the string is I got to get the right length. So we got to make sure the string is on all the wheels properly, like it's not on this one up here properly. And we make a measurement somehow. Very good. Okay. I'm staying totally calm and cool here too, which is, I'm impressing myself. Okay, got the string on every pulley here. I'm sure it's in the actual pulley and not slipped off. Okay, that's good. So every pulley in place. Now I got to get the right measurement, assuming we're using this spring. What I want to do, I need a pen to make a mark. Okay, it's taking all my magic markers. You're there. Hidden from view. Okay, so we're gonna leave this string the way it is, this lower one, because it's virtually in the right place. It's the upper one here. Okay, oh, don't drop it. That's okay. Now, so we could identify the place we want the spring on this string, and then that'll show us what we have to do with the other strings. Does that make sense? Not really. Doesn't really make sense. It's not making any sense. Let's try this. Bring this over. Let's say we'd want the spring stopping about here. Now the spring itself. Okay, that's where the loops have to be. That's where the loops have to be. I managed to drop it right through the hole in the chassis. Okay, got the marks. Now, we'll want to fashion a loop at that location. So we want this to looping like that. Slipped just a little bit in the last moment, but it's very close. You can kind of see where the blue, whoops, can you see where the blue is? Just a little off the center. And now we want to try the other one. Also very, very close. Now the moment of truth, or some truths. Now how do we get this into the loop there? Might still just be in the find out if I got it right mode here. Done this the hard way. Let's do it the easy way. I'm just putting the spring on in sort of a temporary fashion here because I still need to prove it's correct, all correct. Ooh, see the knot got right up in here? Come on. Okay. There we go. Looks like I got good tension. Very good. Wow. It sounds tenser than it really is. very good. Excellent. Does it work? Okay, so we would pretend the pointer is here. And we don't even have to pretend. I can kind of stick it there. The string has to... in the middle here where there's a lot of slack. There. Of course I put it in the wrong spot. We really want it down here somewhere. So I'm going to put it down there. Notice, just a little interesting thing about this that can save you a lot of frustration. If you want to move the pointer, I've explained this so many times, but I will again. If you want to move the pointer that way, you might think I got to steady the string here. Keep it from moving so I can push this, but in fact that will cause this connection here to tighten. You don't want to tighten it, so actually hold it here of all odd things and push towards it, and this is the way to do it. Okay, we ready for the moment of truth. So I'm going to turn this way. It does not feel very good. It feels really tough. I think this spring is too tight. Maybe some string overlaps in here that may be messing things up here badly. Done. It's not straightened out to even start. Yeah, wrong tool. Can you see the cross right in there? Now that might just be a temporary thing. That'll go away if I just work the capacitor here. Oh, I don't think so. Well, sometimes you just go back and forth once and something's just creaking terribly. Okay. Just for this time. It's going to overlap. I don't think this is done right, because this string is coming in on this angle, and it's going to want to be at the front all the time. And the other string that's going down, it wants to be at the back all the time. I think I should reverse this, and I should reverse the piece down there. Yeah, but I'm pretty sure I've got it the way it shows in the diagram. It comes up to the front? Does it come up to the front? Just bear with me while I take a peek here. It takes a while to orient yourself to the thing. Okay, it's the double around the small one. Up, up, and onto the front. That's exactly what it is saying. And on the knob, it should, from the same wheel, come down, go under at the front. Well, I got it going under at the back, but that doesn't really matter. Down there, it doesn't really matter. I got this done the way they show it. But I don't think this is going to work here. I think this is going to be constant trouble here. Coffee time. Okay, so I've reversed the string wrap on the two shafts. So all I got to do is just try to get these together now. But probably the string length is wrong. And I bet you this, I'm going to have to redo the string length. Well, there's not nearly as much tension. Yeah, there's almost no tension. So that's what's happened. You need to put a different spring in there, or change the length here. So I have to shorten this up. Okay. So we want to shorten this up. We want the knot to end up maybe half an inch higher here, about like that. Being Canadian, I have to, and I think a lot of people in the world, you have to know both you have to be fluent in both the imperial and the metric system. It's really not that difficult. The thing. I remember my grade 2 teacher coming in with a meter stick and saying, "Class, this is going to be difficult now to try to, get your head around this." Well, difficult for the adults, not for us kids. The meter stick was as weird as a yardstick. Okay, so this is coming under. We want this to come under. And up. This. Oh my gosh, it looks like it's 16 miles away. Oh, it is. It's 16 miles away here. How did that happen? Because I went half an inch and it's too much. Okay, let's just put in a little slack here. fighting me here. Okay, put this back on the wheel. This will tense it up. Quite a bit. Good. Oh, I think that's good. Okay, I don't think we need that there anymore. Okay, now did I just mess this thing right up? So, turning this way, I expect the pointer to go that way. Oh, for crying out loud. Come on, man. Really? And, wow, what's this, all this jamming up stuff here? Well, that's a definitely backwards. So I have to drink more coffee. I don't know what's going on here. This is definitely better. This is better. This is the proper way. So now I've got the one down below wrong. Supposedly wrong. Is this spring going to crash into there before the pointer gets all the way? Better find out now. Oh, wrong way. Right, everything's backwards. Who's getting hooked there? So what's happened is the string has gotten tangled. It's run over itself on this shaft. The classic string problem here, right in here. Of course, I've manipulated this, and yeah, you know what? I think I got to go and have some coffee here. So let's take the tension out again. Oops. I'm just going to leave it like that. We'll rest a little bit, and then we'll flip that thing again. Sooner or later, I'll get it right. Okay, so I've reversed the string on the control knob. And now I just want to tense this back up by putting it back on the pulleys properly. I've figured out that when you're doing this, you have an opportunity to drop the tension a little bit if you have one of these wheels. There's a shaft in there, and the string can easily be trapped like it is now between the wheel and this, so it can't come off. So while you're working on it, it's not riding in here ready to fall off. It's actually back in here, and this gives you it reduces the tension. So when you're working on it, sometimes you need less tension. So in this case, I was able to reverse the strings down there without disconnecting the spring. Okay, now where are we at now, Jim? Here we go. I'm going to turn it this way and expect the pointer to move that way. Oh, it did it. It didn't do it very far, but it did it. Okay, well that's good. Now the string is on correctly, I believe. And we are unable to advance it. Why is that? So it's slipping around the around this knob. That usually means it's just too much work for the poor knob to do. Probably before I put the string on, I should have lubricated all these little guys here. Now I'm stuck doing it late in the game. But I have a oiler here. Not the thing that just fell, but this has a very, very thin delivery tube. And we're going to deliver just a tiny little amount. Is this really what the problem is? I don't know what the problem is yet. Not much oil comes out of there. I've got some on the string. Doesn't really matter, does it, down in this area? Keep oiling the string here. It's not good. Okay. This I found was all loosened up. Didn't I do that before? Wow. So we're gonna have to try to figure out where this is binding up here. That's a little better. So the knot just went up under here. Isn't that bad? That's bad. Come on. Then we have to slip the entire string, you know, until this knot is up close to here. Position of the pointer is random right now, so it doesn't really matter. Let's just get rid of a little excess string here I don't think I'll ever need. So the string is walking nice. It's walking on here, it's walking down there. What I mean by that is when you have it spiraled around something and you turn it, the string begins to travel along the surface back and forth. There's allowances made for that in these. Like, that's why this is so wide here. Hey, how come it's working nice now? Okay, knot contact. Maybe the oil I put in is just, it's definitely rough. Like the movement's not smooth. It works good in one direction, which is probably the direction that tightens it, and the other direction loosens the string a bit. And that slight loosening is enough to get it to slide on the well, I don't know. What is keeping it from moving so easily? Did I not lubricate all of this? Or am I thinking of the last radio? Maybe I'm thinking of the last radio. No, I'm pretty sure I did this. Ooh. What was that? That's the knot disappearing up there. I think that's what we heard. The string is getting on top of itself here. Why did it do that? The string is almost more, you know, the most complicated thing in the radio. The string. Uh-oh. Uh-oh. This is Sometimes you got to get these guys straightened up once, and then they'll stay okay after that. There. I think. Pulled across really quick. Now it's going to start going over top itself right here. You think maybe I've got too much tension in the spring? I don't think so. All the way almost. Ooh, did you see that? Boom. Yeah. Did I lubricate this? Well, maybe I did. Maybe I'm thinking of the last radio. So we're going to do this. Here too. Here and there are a little tough to effectively lubricate. Give it a shot. Stuck because the string is going over itself. No. No. Why did it stick? So the sound you're hearing, I believe, is the spring, coming from the spring. As I move this, it's stuttering. As it stutters, the tension goes up and down, and the spring is being stretched like this. And I think that's what we're hearing. That creaking sound. Sounds like it's going to blow any minute. Tension went way up right at the end there. Why is that? So here we got that note. The string popped here. Getting better every time I do this. So it just needs to be worked. Missed it again. The only thing that can make that sound is right in here, I believe. Too bad the string races over to the far side. There, you saw it that time. It's falling off itself here. Okay. Probably the thing to do is kind of just leave it this way for a while and work with the radio, get the pointer positioned and carry on further. This may loosen up over time from just working it back and forth. And Like that. I must be thinking of another radio. Makes a huge difference right there. But not on this. Not on the slippage. Sounds the same note all the time, same tension. Maybe a little higher there? Maybe because the string has gone over top of itself here. I've actually pulled out a little more tension, changing the pitch of the string. That's getting better every time. Come on, you can do it. You did it. He's done it. So let's go back and check the end here. Right there is the limit. You see there's still more capacitor to go. So what I have to do is I have to slip the capacitor here. Now how can I take off tension? I'll take off tension, but I don't really want this moving. Take off tension the other way. I got oil on my fingers. Because the string is wound on top of itself, it's kind of locked on there. I have to go down to the other end. Keep going. Okay, now I want to slip the string. This. This should not be all the way open yet. How sensitive is your hearing? So I can hear a voice way off in the distance. It's my CB radio. Yes, I have a CB radio going all the time. So I can spot when the skip is up. Okay, so this knot is hitting here now. So this should be all the way down at this point. Okay, knot hitting here. Does the knot hit the other side? Did I end up with my knots too wide? Boom. Okay, so I succeeded there. Yeah, when I tied this, I tied these knots too far out. It's okay though. I think it's okay. This is all the way. And we can still go all the way the other way. Ugh. Don't like it. What did I say earlier about just leaving it for now? Yeah, I think that's a good idea. I can get along. I can do a lot with this like this. There it is, the string. You know, I'm worn out. That's enough stringing around for me today. That's it for yesterday and today, in fact. So tomorrow we'll start looking at the sensitivity and alignment of the radio. Get the pointer in the right place. That's a little challenging because the glass dial is in the cabinet. So anyway, well, thanks a lot for watching. Strings are tough, and string videos are tough too, I guess. So have a good day, and tomorrow I will get back to some more kind of electronic sort of stuff. See ya.